Okay. All right, section 11.6, volumes of pyramids. So our objective for this lesson is to find and use the volumes of pyramids. Again, still talking volume. And again, in the last section, we talked about the volume of a prism. Again, we had that volume of a prism. If you don't remember from the last section, volume would equal the big B, which is the area of the base. So that's the base area, times the height of the prism. It's the height of the prism, not the height of the base. Okay, and in my last video, in the video I had you watch previously with the water, we noticed that a pyramid has a smaller volume than a prism, and even more so, it has 1/3 the volume of a prism. So our equation for the volume of a pyramid, okay, is very similar. We just have that 1/3 idea. The volume then of a pyramid is 1/3 area of the base times the height. And again, this little guy here is just the volume formula of that corresponding prism. Okay, so really what's nice is we don't really have any more equations to remember. We just have to remember how the volume of a pyramid and a prism relate to each other. So that's kind of nice. Okay, so if I want to find the volume of the pyramid, so this volume, again, volume is going to be equal to 1/3 big B times H. And a lot of times I write the big B and the H in the numerator, big B and H. Okay, so that way we can, we know it's over 1. So now I need to find the area of this base. So first we have to figure out what that base is. If we look here, this base is a triangle. Okay. That base is a triangle. And it has a nice 90-degree angle in there. So I'm going to sketch that off to the side. So we have, that is just the base. And this side here, again, this side here is a 4. So I'm going to go ahead and label this as 4 meters. And then this side here, this side right here is 6. So we're going to label that as 6 meters. So we have that nice right triangle. So I need to find the area of that right triangle. That would be my big B, the area of that triangle. So the area of a triangle is 1/2 little b times height, base times height. So 1/2. My little base is 4. The length of that base, again right there, is 4. My height is 6. So 4 times 6 is 24. Half is 12. So my big B is 12. So then now I'm just going to come and plug this over into here for my big B. So we have 1/3 big B, which is 12 times 12, times my height. That is the height. Again, remember this height right here. This height is the height of the pyramid. It's that straight up and down perpendicular height, this straight up and down perpendicular height for that thing. And it gives us that there in pink. And it shows us, it makes a 90 with the ground, so I know that's a straight up and down, so I know it's 9. Okay, so I'm going to take the 1/3 times the 12. 1/3 of 12 is 4. Times 9 gives me 36. My units are in this meters cubed. Do not forget your units on your homework, please. Some of us have been forgetting that. Please put our units. Okay. All right, next one. Okay. Originally, Khafre's pyramid, it's a famous pyramid in Egypt, had a height of 144 meters and a volume of about 2,218.800 cubic meters. Find the side length of the square base. So we have a pyramid with a square base, so all these sides are the same, 90-degree angle, and it comes up to a point right here, again, that pyramid. Okay, not the best drawing, but there's my pyramid. Okay, and it had a height, so I know the straight up and down height. From the top to the bottom, the straight up and down height is 144 meters. And I know its volume is 218,800 cubic meters. We want to find the side length of that square base. Okay, well, we know volume of a pyramid, again, is 1/3 big B times H. So let's go ahead and let's plug in what we know. We know the volume of this pyramid is 2218800. That's going to equal 1/3 big B times the height of 144. So I'm going to multiply the 1/3 times the 144. Okay, so 1/3 times 144. I'm going to get my calculator on that one. 144 is the same as divided by 3 is 48. So when I multiply the 1/3 times 144, I get 48. So we have 48b equals this thing. Divide both sides by the 48. Okay, so 2218800 divided by 48. Okay, so I got big B equals 46225. But that's the area of that base. That base is, they say, find the side length of the square base. They tell me it's a square base right there. So I know the base is going to look like that. 90-degree angles in each corner. All the sides are the same. I know the area of this base is 46225. We're trying to find the length of one side. So let's go ahead and let's label that as x. We're trying to find that. Well, since it's a square, I know it's the length of that side as well. So the area for this is found by taking x times x, which is x squared. And my area is 4625. So if we replace that in, 46,225 has to equal x squared. So then x would equal the square root of that. Well, let's see if that's a perfect square. I have no idea if it is. 46,225. Oh my gosh, it is. X then would equal 215. And my units there are meters. That's how long this side length is. That's how long this side length is in my original pyramid. It's 215 meters. It's the length of one side. Okay. Next one. Here, find the height of the triangular pyramid. Okay. So here we want to try to find the height of this guy. I know its volume. They give us that. Its volume is 14 cubic feet. Okay. We know the base and height of the triangle that's the base here. So our triangular base, crooked. Our triangular base, here's our base. A lot of times it helps to draw the base over on the side as 2D. We know this is 4 feet, and we know this height right here, that perpendicular height, they give us that. This little distance right here is 3 feet. So I can find the area of that base. So we know the volume of a pyramid is 1/3 big B times H. Okay. So my volume is 14 equals 1/3 big B times H. I don't know the big B, but we can find it. Let's come over here to our base. There's our base picture, and let's find the area of that base. Big B equals, it's a triangle, so it's 1/2 little b, the base of that triangle times the height. So we'd have 1/2 times 4 times 3. 1/2 times 4 is 2 times 3, so we end up getting 6. So the big B, the area of that base is 6, so we'll plug this B over here in for that B. So we now have that 14 equals 1/3 times 6 times H. 1/3 times 6 is 2. Divide both sides by 2. My height is 14 divided by 2 is 7. 7, and we're in feet. So the height of this pyramid is 7 feet. Okay, next one. Okay, this one tells us Pyramid A and Pyramid B are similar. Find the volume of Pyramid B. They tell me the volume of Pyramid A. They give me that right there. So we're trying to find the volume of Pyramid B. But I know that the scale factor, I can find the linear scale factor. The linear scale factor of our linear measurements, our straight line measurements, our length. Oh, sorry. Linear. I don't know why that jumped ahead. Our linear measurements of the scale factor, because we know the height of this one's 8, the height of this one's 6, and we know that they are similar. So I'm going to set up the scale factor. I'm going to go big to small, the bigger one to the smaller one. The big one has a height of 8, the small one has a height of 6. They both divide by 2. My scale factor is 4/3. That's the linear scale factor. So the ratio of the volumes, the ratio of the volumes will be the cube of those, again, because volume is cubed units. So I would need to take the 4/3 cubed, and that's the ratio of the volume. So 4 cubed. So I need to take 4 times 4 times 4. 4 cubed is 4 times 4, 16, has 4, 64. And then 3 cubed, 3 times 3 times 3 is 27. So this will be the ratio of their volumes right there, that guy right there. So if I put the big volume over the small volume, I should get 64 over 27. So let's go ahead and let's do that. The big volume is 96 over the small volume is what we're trying to find, would equal 64 over 27. So since I have an equals in between here, I'm going to do a little bit of cross multiplying. So I'm going to take the 96 and multiply by the 27. Again, take this 96, multiply by the 27. I get 2592. And then I'm going to take the 64 times the V. Okay, and then I need to multiply both sides by the 64, divide both sides by the 64. Divide by 64, our volume is 40.5, and that would be cubic meters. So that is the volume of my smaller pyramid. Again, that's just using that, and this is from our previous section, our section on prisms, that the ratio of the volumes, again, is there's the scale factor cubed. Okay, next one. Ooh, a composite solid. So I want to find the volume of this composite solid. So what I have here is I have a square pyramid. This guy is a square pyramid on top of a square prism. So to find the volume of this composite solid, composite just means it's made out of more than one basic shape, more than one solid, is I would need to add the volume of the two of them. So let's find the volume of the square prism first. So my square prism, the volume would just be big B times the height. So now I need to find the volume, the area of the base, my big base there. It's a square base, so it's just length times width. So my big B here would be 6 times 6. And then now I need to multiply that times the height of the prism. The height of that prism is 6. So if I take 6 times 6 times 6, I get 216. And that would be cubic meters. So that's the volume of the prism. So now let's find the volume of the pyramid. It would be 1/3 big B times H. So 1/3. Again, my base here is that square. There's my square. So my big B here, let's do that in red, would be 6 times 6. And then I would need to multiply that times the height of that pyramid, which is also 6. Oh, a lot of 6's in this problem. So I have 1/3, 6 times 6 times 6. Well, we know 6 times 6 times 6 is 216. So I just need to take 1/3 of that, which is 72. So the volume of this is 72 cubic meters. So I would need to add then the 72 cubic meters plus the 216 cubic meters will get me the volume of that solid, 288 cubic meters for that entire solid. Okay. And all done.